In this video, we're talking about the interesting things that happen when we have intersecting tangent and secant lines on a circle. And we have a couple reminders here. We're going to be applying these to this example problem here. But when we have a circle and we have two tangent lines to the circle that intersect, remember that a tangent line is a line that just touches the circle at one point. So for example, if I have this circle here and I have two tangent lines, tangent line AB and tangent line AC, AB is tangent to the circle at the point A because it only touches the circle at that single point. Line BC here is tangent to the circle at point C because it only touches at that single point. So these are both tangent lines, and when we have two tangent lines that intersect one another outside the circle, what we can say is that the tangent segments are congruent. So in other words, segment AB is going to be congruent to segment BC. So these two segments are going to be congruent. The distance between the point of tangency and the point of intersection on both tangent line segments are going to be equal to one another. We also know that when we have two intersecting secant lines, that the product of the length of the secant line inside the circle and the length of the secant line outside the circle is going to be equal to the same product for the other secant line. So that's like this example down here. We have circle X, we have all these points, but RW is a secant line. Remember, a secant line is a line that cuts through the circle at 2 points. So RW cuts through the circle at the point R and the point S, so it's a secant line. And we also have the secant line UW. It cuts through the circle at the point U and the point T. So we have two secant lines. They intersect one another outside the circle. And what we can say then is that the portion of the secant line inside the circle, so for the line RW, that would be the portion RS, so RS, times the outside portion, or the portion of that line that's outside the circle, so that would be this portion here, SW, so times SW, has to be equal to the same product for the other secant line. So the portion of this other secant line that's inside the circle is the line segment UT, or the chord UT, so we would say UT times TW, the portion outside, so we would have TW. So we know that this is a real relationship between intersecting secants. And similarly, if we have a tangent line and a secant line that intersect one another outside the circle, so we have one tangent line like these lines here, and we have one secant line like these lines here, and they intersect one another outside the circle, we would just take the length of the tangent line segment, like for example up here we would take the length of AB, we would square it, and that would be equal to the product of the length of the secant segment inside the circle and the length of the secant segment outside the circle. So for example, this UT times TW, this value over here on the right hand side of this equation. So we've got a couple different rules here. Let's apply them to this figure. So we have this figure here. We've been asked to find two pairs of congruent angles. And this is another interesting fact about intersecting secants. When we have intersecting secants, so we have this secant line RW and this secant line UW, if we connect opposite intersection points, so we connected S to U and we connected R to T to form these lines here, notice that we have two triangles that are formed. We have the triangle UVT, this triangle here below, and then we have this triangle above here, RSV. So we get two triangles that are formed. Well, when you have intersecting secants, the two triangles that you form this way are always going to be similar triangles. They won't necessarily be congruent triangles where all three interior angle measures and all three side lengths are congruent. Instead, all three interior angle measures will be the same, but the side lengths may be different. So one triangle might be larger than the other, but the three interior angle measures of these two triangles are going to be congruent, and therefore we would call them similar triangles. Because they're similar triangles, we can also identify congruent angles. So for example, this angle here we know is going to be congruent to this angle here because these two are similar triangles. We also know that this angle will be congruent with this angle, and because they're similar triangles, or just because we have two intersecting lines and we can call these vertical angles, these two angles will also be congruent with one another. So if we want to identify two pairs of congruent angles, we could go ahead and say that the angle SRV, so angle SRV, is going to be congruent to angle TUV, so angle TUV. We could also identify this other angle here, RSV, so angle RSV is going to be congruent to angle UTV, so angle UTV, and we can identify this third set of vertical angles here, angle TVU is going to be congruent to angle SVR. R. Now, there are actually other congruent angles in this figure, which we'll see when we talk about similar triangles in the figure. We already know that triangle RSV and triangle UTV are going to be similar triangles because we identified those earlier, but we also have a second set of similar triangles when we have two intersecting secants, and this will always be the same. So if we look here and we identify triangle UWS, so this triangle right here from U to W, W to S, and S back to U. So this triangle right here is actually going to be congruent with this triangle here, RTW. So from R to T, from T to W, and from W to R, these two triangles are also going to be similar triangles. They won't necessarily be congruent, they won't necessarily be exactly the same size, but they're going to have the same three interior angle measures. So we can say triangle RWT and triangle UWS are going to be similar triangles. So we've got similar triangles, and keep in mind then that if we have these two here larger similar triangles, then we can go ahead and say that this angle here, RTW, so angle RTW, is going to be congruent to angle USW. And that's these two angles right here that are congruent. We already know that this angle R and angle U are congruent. We already listed that. And angle W here is going to be the same for both of these larger triangles. But this is a fourth pair of congruent angles that we can list in light of the fact that we have these two sets of similar triangles.